Dear students, welcome to the video Mode and Expectation of the Geometric Distribution. All the geometric distributions have one feature in common, which is that probability of x is equal to 1 has the highest probability among all trials. So for all geometric distributions, mode will be equal to 1. And for the expectation, it is the first point. For the expectation, we know that for a discrete random variable, expectation is sigma x, probability of x is equal to x. Now applying the geometric distribution definition and formula, you will get that expectation will be equal to 1 over p for all the geometric distributions. Now let's see some examples. Example number 1. One in 4 boxes of Zingo breakfast cereal contains a free toy. Let the random variable x be the number of boxes that a child opens, up to and including the one in which they find their first toy. Part A, find the mode and expectation of x. Now, as given in the question, 1 in 4, so p is 1 over 4. Now, mode for all the geometric distributions is always 1. But expectation is 1 over p, so is 1 over 4, which is 4. Now, for part B, interpret the two values found in part A in the context of this question. Now, mode is 1. It means that a child is most likely to find their first toy in the first box, because mode is 1 in the first box. And this expectation is 4. It means that on average any child needs to open 4 boxes to obtain their first toy. So on average a child needs to open 4 boxes to find their first toy, because expectation is 4. It means that 4 boxes should be open to obtain the first toy. Example 2, the variable x follows a geometric distribution. Given that expectation is 3.5, find probability of x greater than 6. So expectation, which is 1 over p, is equal to actually 7 over 2. Therefore, p will be 2 over 7. Then q is 1 minus 2 over 7, which is 5 over 7. Now, probability of x greater than 6 is equal to q to the power of 6. Now, 5 over 7 to the power of 6, giving you an answer of 1.133. Example 3, given that x has geometric distribution with parameter p and probability of x less or equal to 3 is 819 over 1331. Part A, find probability of x greater than 3. So it's clear that probability of x greater than 3 is 1 minus probability of x less or equal to 3. So 1 minus 819 over 1331 gives you 512 over 13, 31. Now part B. Now we need to have P or Q to solve this question. We know that probability of x less or equal to 3 is actually 1 minus q to the power of 3. So we have probability of x less or equal to 3, 819 over 1331 is equal to 1 minus q to the power of 3. Now q to the power of 3 will be 1 minus 819 over 1331, then q to the power of 3, take cube root from both sides. Q will be 1 minus 819 over 1331. Then q will be 8 over 11. Therefore, P is 3 over 11. Now, probability of x is between 1 and 3. It means that the number of the trial on which you get your first success should be something between 1 and 3 inclusive. So x can take either 2 or x is 3. X is equal to 2, it means that the first trial is failure, the second is success. X is equal to 3, it means that the first two trials are failure and the third one is success. So it will be P, we found P is here, 1 minus 3 over 11 times 3 over 11 plus 1 minus 3 over 11 to the power of 2 times 3 over 11, which will be equal to, at the end, 456 over 1331. Thanks for watching this video.